In this video, let's talk about BST preorder traversal. Here is a problem. We want to preorder traversal BST with both recursive and iterative approach. And preorder traversal, we first visit the current node, then we visit the left node recursively, then we visit the right node recursively. That means we first visit this node, and we visit this node and this node. So what we should output is 1 and 2 and 3 and 4. How to do that? Let's take a look at a more elaborated tree. Here is our tree. In order to recursively traversal in order, we just do what we describe. We first visit the current node, then we recursively visit the left branch, then we recursively visit the right branch. After that, we just we just pre-order visited the tree. For example, here we want to give us a root. We call this code recursively. We first add the 1 to the final result, and we visit the left node recursively, which brings us here, and then we add a 2 to the final result, and then we call this line, which brings us here. We add 3, then we recursively call this line, which brings us here. Now we are after add 4, we recursively call this line, and here it's a null node, so we got this exit condition. Then we came back, and then the right node is also null, so we came back, and then we just trace back. We go to node 3. We just finished this line, so we need to run this, which brings us node 5. After add node 5, we just we exit from here. We just exhausted the left branch of node 2, so we visit the right branch of node 2, which brings us here. And after that, we will run this line, which brings us here. And then again, we go this line, which brings us here. After add those, we trace back and run this line. This line brings us 9. After add a line, we just finish this right branch of node 2. So we exit from here, and after that we just finish the left branch of node 1. So we have finished this, and then we run this line, which brings us to this node. And this node we add it, of course. Then we examine the left node, which is null, and then we go run this line, which is the right node. Right node brings us here, and we run this line, which brings us here. After add 12, we just go run this line, and here is null. And then we just exhausted the right branch of node 1, and we exit. In that route, we just visited the tree in this order: 1, 2, 3, 4, then 5, then 6, 7, 8, 9, then 10, 11, 12. As you can see, the visiting order is we first move to the leftmost node. On this path, we print out the path, and then we trace back. When we trace back, we examine the right node. If there is right node, we go to the right node, and visit its subtree. Then we trace back. If there's right node, we go to visit its subtree. Here again, in order to visit the subtree, we first go to the leftmost node, and we also print this route, and later we trace back. We examine where the right node. If there's right node, we go visit this subtree. Finally, we go back, and we just visited the whole tree iteratively, recursively. So this way, this is how the JVM caller stack implicitly work. If we write a iterative code, we can see how the core stack is arranged explicitly. So here is a iterative code. We just do what we just described. We first go to the leftmost node, and we add the path to our final result. We also remember the path, so later we can trace back. In this while loop, we trace back. When we trace back, we examine the right node, right? We examine the right node. When we examine the right node, we do the same. We first write to the leftmost node, and here rightmost node, and we add the path into our final result, and we also remember those paths, so later we can trace back. And after this while loop, we just visited the binary search tree in preorder iteratively. Let's take an example. We first have this node. We start from the root node, and our stack start to build. We add 1, then we walk to node 2, we add 2, then we walk to node 3, we add 3, then we walk to node 4, we add 4. After that, we start to trace back. We pop out 4, and we examine if 4 have any right node. There's no right node, so we pop out another node. 3, we examine if 3 have right node. Yes, 3 have right node, so let's add a 3's right node. And we check in this while loop, 5, do 5 have any left node? There's no left node. We are done with this node, so let's pop out a 5. Pop out 5, let's examine if 5 have any right node. There's no right node, so we pop out another node, which is 2. 2 have right node, so let's add a 6. After add 6, we are not done yet. We examine the left node of this node, so let's add 7. Then let's add 8. 8 don't have left node, so we are out of this while loop. And then we pop out the next element, which is 8. 8 don't have right node, so let's pop out another. Pop out 7. 7 don't have right node, so let's pop out another. 6. 6 have right node, so let's visit that right node. Let's add a 9. And 9, let's see if 9 have any left node. There's no left node, so we are done with this node. We go out of the while loop, we pop out the next element, which is 9, and we examine 9 don't have right node, so we are done with 9, and we pop out the next, which is 1, and we examine 1 have right node, so let's add it. 10 don't have left node, so we are done with this node, so let's pop it out, and it have right node, which is 11. Let's add 11, and we examine if 11 have left node. Yes, 11 have left node. Let's add the left node. 12 don't have left node, so we are done. We out of this while loop, and let's pop out the next element. 12. Let's examine 12 don't have right node. We are done with 12, and let's pop out the next, which is 11. 11 don't have right node, so we are done with 11. Then our stack is empty. Then we are done with this iterative approach. And again, exactly we visit the tree the same way as the recursive approach. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is preorder traversal of the binary search tree.